So let's say your plane 1 is 3x negative 2y plus z equals to 5. Your plane 2 is 3x plus 3y minus z equals to negative 1. So what can we say then? How do these two planes interact? Right, both of you again. Are they parallel, firstly? Are they parallel? Can someone tell me why not? Apa yang tak sama? Direction dia tak sama. Okay, the direction is not the same. The normal are not the same. So the first normal is 3, negative 2, 1. The second normal is 3, 3, negative 1. So they are not parallel. So they might look something like this. Okay, this is diagonal, this one here. So now how do we calculate the angle between them? Okay, what do we get? What other information can we get from them? Normal, right? So what can the normal help us to find the direction? To find the angle? So let's say they are something like this. Okay? Look here very carefully. So this is the normal. Alright? And I can slide this one down. Still the same normal, right? I can slide this one over here. Still the same normal, right? So now we got this. Now we got this. Yes, they cross. When the normal cross, yes, we can find this theta. Okay? It's not it crosses when they intersect lah. Which formula should we use? Which formula should we use? Before we begin the class, I ask you something. Thank you. Sorry. Okay. Sorry, this is not included in the video just now. There are two formulas for you to use: A, B, modulus A, modulus B, cos theta. The other one is A cross B, modulus A, modulus B, sin theta and hat. Which one should we use? Well, we prefer to use this one. It's easier for us to calculate. Alright. What's your A? What's your B? A is what? One of the normal. 3, negative 2, 1. What about your B? The other normal. 3, 3, negative 1. Okay, I'm sorry we are running out of time and the calculation takes a lot of time. The answer should give you, I need to skip for this part, 82.96 degrees. Try it later and show it to me in the class. You okay? Final example. Okay, I don't have enough time. So angle between line and plane. Let's say the line is, one moment, 2, 3, -1, 1, -1, -2, and let's say the plane r dot 1, 1, -1. Just now, if the angle between two planes, how do we calculate? We take the normal and normal, right? Use the formula when we get the answers. But for line and plane, they are very similar. We still want to use both direction. We're still going to use A dot B cos theta. We are still going to use this formula. But for this case, we take the normal and the direction. Okay? So what's your A and what's your B? Doesn't matter. You can take A as this. You can take this one as your A. You can take this one as your B. Or vice versa. The main idea is you need to take the Can I take B and 2, 3, -1? I cannot. Why can I take not? Why I cannot take this? This is a point. You need direction. Then only this formula works. Okay, here comes the catch. This is what makes the difference between A and A minus student. For angle between line and plane, what's the answer you're going to get? It's 90 minus theta. That's your answer. Once you get this answer, you need to do this, 90 minus theta. This is the only difference. Between, like, if line and line, you just use this. Okay, so if line and line, or plane and plane, this where you stop your answers. You got theta and that's it. If plane and line, what do you need to do? 90 minus theta. Plane and line, 90 minus theta, that's your answer. And you want your answer is acute angle. Alright, I think that's all for today. The calculation is long, not suitable to sheet. Okay, so take this question and we discuss it in the class. The answer is supposed to be, if you manage to calculate, this here, 61.87. So final answers, 2813. Okay, that's all. Thank you very much.